welcome. This is for custom types and classes, chapter 13, the video recording. What I'm going to cover in this is basically how we design classes and use them in Python. I'll contrast this with Java and C# when it is necessary. And my main goal here is to kind of create an example for you that you can take and adopt. So the coffee class can be, generated based on the example that I'm going to be given in this next couple of hours. All right, so what I want you to do is before you start any of this, I want you to go find lecture 12 code. This is going to be a zip file under this video, and then of course slides for this chapter. So in this file, if you notice that there are a bunch of things going on. So what I'm going to do is I will be using an example from the textbook, which is called bank accounts example. And what I did is I took the bank account example from the textbook and I created two versions of it. One is called bank accounts textbook, as you can see, _textbook. So, and we have two files associated with that example. And then I have bank accounts example. And that's basically what I did is I took the bank account example from the textbook. It was good, but it was not really good enough. So, do interesting things with classes. So I kind of embellished it, added a menu, and I added new methods to the class so that it's more kind of parallel to what you need to be doing. Of course, that also allows me to introduce a lot of different things and neat ways of creating and using Python within that example. So there are two sets of examples. One is bank accounts textbook, which is relatively kind of a skinny version of it, so it's easier to grasp. And then there will be a bells and whistles version, which is called bank accounts, and that will be kind of a bit more complicated version of it. So we'll work with both. And if you notice that I do also have two text files, accounts data and accounts textbook data, which will be used. I also added my accounts objects file. It's basically later on when we use this, you'll notice that we'll be writing objects to a file and reading them. So this is my version of objects. At some point, once you can actually load this and look at my objects as well. So it's there, so it's available, and I'll be creating this and using it throughout this video anyways. All right, so we're going to start with classes. Why do we need classes? Why are we creating a coffee class? And what is the point of a bank account class? So let's get to it and let's talk about that. That's the first thing we'll do. All right. So let me move this over. So we'll talk about the difference between the two. Classes and object-oriented programming and procedural programming. So in the procedural programming, the goal is to write programs, and which basically is made up of functions, so that it can procedurally, based on your user actions or your own logic, do a set of tasks. Okay, but the focus here is to create procedures that operate on programmed data. Okay. In object-oriented programming, it's a little bit different. So what we do is we focus on creating objects. So instead of working on the data as a whole, we work at each individual object at a time. So what do you mean by object? The object will be, in your coffee example, will be a brand of coffee, right? And in our example here, the bank account will be a bank account that belongs to a specific customer. So when we think about it in the object way, so it will have data, it will also have procedures. For an example, coffee example that we used, an instance of coffee, which is an object of a coffee class, will have its data, right? The data will be, it's basically 4 parameters and the brand name. And then if you look at the bank account example, the bank account may have many attributes of its own, but the basic attributes that we will focus on will be the account ID, account name, and then the balance of the account. Okay, So what we will do is we'll kind of hide this information from outside world. So this data will be hidden. We will allow outside worlds, or when I say outside world, we're talking about client code that tries to access this class. We'll not be able to see the details. We can hide a lot of things like data points, and then but still allow them to do certain operations, deposit, withdraw, and create a new coffee object, display them, and so on. And we'll discuss how this is done within the context of classes. So this is called encapsulation, combining data and code into a single object and kind of hiding it as well. So what will be then the methods? We said procedures. So these procedures are basically like in your coffee example, be able to calculate the values of Q, TAC, and T. So you will not have this in the client code, but inside your coffee class, the class itself will know how to calculate these parameters or values of interest for a given coffee object. So we're going to hide this also inside our class. Similarly, in the bank account case, there are, as you'll see soon, we'll have a deposit, withdraw, and then we will have ID and a couple of other methods that later on we'll introduce even more to allow the inner workings of the class to work, even though we are hiding much of the detail from outside world, from the clients. Okay. So in an object-oriented world, we basically take attributes and methods and encapsulate them into what we call an object. Okay. So we hide data. We also allow this object to be reused. When we create new instances of this object, each instance will have access to its own data. It also have access to these methods that are defined inside the class, right? And what we'll do is this kind of will hide an encapsulation, will allow us to hide things from outside, but also will allow us to protect the object's integrity so that there's no corruption in its values. Okay. Like for instance, the rules about balance, right? So you're maintaining the balance should be all the beginning balance and all the withdrawals, right? All the deposits. So the withdrawal balance, that formula should stay constant. So you don't want any program to mess this up. Okay. Right? So outside code will talk to the object and we'll ask it to run certain methods and we'll ask it to give certain kind of data. You can do other things as well, right? So we'll design all this. So we'll basically talk about, we're talking about this bank account class. So it will have a bunch of data members, account number, name, and balance. Then it will have a couple of methods. And then we'll have also, these are called public methods, deposit and ID, so that the client code can use it directly. And then we'll have also private methods. These private methods will be hidden inside our code, and it will allow us to do things such as printing an object, or checking to see if the two objects are equal, or trying to see if you can sort these objects in one way or the other. So decide how they define equality and how they define what is greater than, like in terms of coffee objects, what does equal mean? And also similarly for coffee objects, what does it mean to sort them? How do you sort them? Which attribute? So we'll talk about those private methods as well. I'll show you some examples of that in the advanced version of bank accounts example. So the classes, so like bank account and coffee, will be kind of a overarching abstract structure, and the instances will be instantiations of this using the code and building values out of it, right? So similar to, you can think of it as you have a blueprint or a bank account, but then each instance is a customer, each instance is a coffee. Okay. So the definition will have this class inside, and then we'll basically go and talk about how we define the class. So we define the class by its name, and then inside of it we decide what values we'll have and how do we set these values for an instance, and then what other functions that we will have or methods will be available. So what I'll look at it now is I'm going to look at the class definition for bank account. I'll go to the code, but for now I'm going to stick here a little bit. The first method that we're going to define within any class in Python is called the initializer method. And this is also called constructor. So remember your constructor from Java, it basically initiates an instance of an object. So of course the instance of an object will have data members, so that means parameters. So when you call this initializer, you're basically passing parameters so that an instance can be created. So in Python, this is the init method, initializer method, and you notice that it has these double underscores at the beginning and at the end of it. And you also notice that it has self that is basically coming into it. So this is equivalent to Java's this. Okay, so remember this from Java. So this is equivalent to that specific operator. Okay. So we'll talk about why we have self and why do we use it and why is it more critical to use it in Python than it's in Java. And then you can basically, once you have the class defined, you can now create an individual instance, like my instance class name, and you notice the class name has these parentheses at the end of it. It's basically calling the constructor. In this case, it calls the default constructor. You don't have to have a default constructor. In my coffee class, I don't have one. So I only have what we call an overloaded constructor, where I really expect brand name, demand, and cost parameters from the user. So once those parameters are given, I call the constructor to create a new instance. Right? And then you can, once you create your instance, then you can access some of the public methods using myInstance.method, and if the method requires parameters, you pass the parameters to it.
Let's do a little example. So far we talked about creating strings, and we said we can create a string using just the string itself. All right. What actually we are doing here is we are internally using what is called the constructor for the string class. Okay, because this object that we created, if you look at the type itself, S, you'll see that it is a class called string. So this is an internal class built into your Python interpreter. And once you have this class, now you can use methods of this class as well. But as a matter of fact, you can actually use the constructor inside. You can say use the str. This is the name of the constructor. So far we have used this and we call this a casting. But as a matter of fact, this is actually the constructor of that string class. So I can actually take this object that I was creating. So this is basically, it is parameter. So the string class takes one parameter and uses, this is now called using this class's overloaded parameter because it takes an overloaded constructor. So now if you look at S, you'll see that it's going to be hello dear as well. And if you look at the type as well, you'll see that it's going to be string class. Okay. What if you just do str and give nothing? Okay, it still works. And if you look at S now, will be what is called an empty string. So this is basically called a default constructor. If you don't create anything, any parameter, this is how it works. You also know that the parameter, this actually works with numbers too, right? So I can take 5, right, and it will turn it into a string 5. Okay. So if you have nothing inside in the parentheses, it's called the default constructor. And if you have something inside, this is called the overloaded constructor. So this is how the constructors work. Once we have the constructor, now I can use various methods like lower. So let's, for instance, do this one first. Okay, and now what I can do is I can just say s.lower, because once I have an object which belongs to the string class, I'm allowed to use its method. And now I can use that method to make this whole thing a lowercase. And we also had a method called format. We have seen this. There are split and a bunch of other. So for instance, I can do s.split, and I can just say split by default. You'll see that what it will do is it will give me default. By default, it's going to use the space as the delimiter, and it will give me all the words as a list. So it creates a list of the words in my sentence or in my string and using a delimiter. So if my string was something like this, let's reset my string, and suppose I had let's say slashes, hello dear good soul, I can actually split it using in this case I can just say split is using slash. Okay, right? So now it's going to split using that slashes. Okay, so this is very useful later on when we do text analysis. This summary. So you notice that Python allows us to use built-in classes or create our own custom classes. So this chapter is basically talking about how we create a bank account class, and I'll show you also how we create a coffee class, and then use methods we developed inside the class. And when we create instances, we are allowed to use those methods, like the string class, lower method, split method. We'll be able to have coffee class, will have its own methods that we can use, or the bank account will have its own methods. All right, let's continue.
Okay, so this is, so if you notice, the self has to be passed, and this is basically a reference to self. This has to be passed automatically. Okay. Now, once we have the class built, then we can build these other programs, client programs, that will use these class definitions. Just like we did with other modules, we can put these inside a module, and then once they are in the module, then you can actually go ahead and access them. So some of the object attributes will be private, and the private ones are actually have what we call double underscore, 2 underscores in front of them, like balance, we'll see shortly. And any variables that are not prefixed with self are treated as normal local global variables. This is different than Java, because in Java, remember, you have declare variables. So when you declare variables, what that means is you're telling the Java class that this specific variable is local, because you have to redeclare it to make it the local. But in Python, this is not what we have. What we have is the variable is not declared, so that means when it's used, it is created. So because of this, what it means is we basically need to make sure that we are referring to the class variable, instance variable, but not a local variable that needs to be recreated. So because of this, throughout the code, you will see that we're going to always use self.balance, self.whatever the attribute name. Okay. And then once we have the classes, we can then store them in modules. Okay, so we can just put them inside the modules and then store them. Java, that you had public, private, protected, these access modifiers for your class variables, and also for methods. In Python, we really don't have this. So what do we have is a bit different, because the way the variables are declared in Python. So we have something very similar to it, but it's not exactly the same. So the underscore, you can create a variable without an underscore. Okay, so that becomes a fully public variable. Then you can create a variable which you use a single underscore. Single underscore means the variable is kind of semi-private, right? So it is not really public, but it's semi-private. What that means is it's still accessible from outside. You can use a name like, let's say my class dot underscore, let's say balance. So, but you're not supposed to. So it is a suggestion that this variable should not be accessed by the client code directly. However, technically it's possible. So when you put double underscores, then it becomes fully private. So that variable now becomes not accessible outside of the class. So if you really need that variable to be accessible, then you have to create a method so that it can return its value. Or you can create a method that can actually modify its value. So there has to be an access methods so that the write and read can be done. Double underscore is fully private, single underscore is semi-private, and no underscore means it's public. Okay, so here's an example. Here we have, so we have basically a variable. We define a class. So inside the class definition, we have there is a public variable and then there's a private variable. So the notice this has to be indented. Realize that. So this is public. You notice there is no underscore and there is the single underscore. So this is single. So what that will allow us to do is for public variables, this is what you should do, and for private variable, right, this is possible but not recommended. Instead, you need to have accessor and mutator methods to do this. Okay. Finally, the real private, which is what I will be using and what I want you to use in your assignment, is to create variables like this example. This is from our bank account example we'll soon see. You basically create these two data members, account number, customer name, and funds available in the account. You notice they all have this double, these are double underscore. Okay. And double underscore is sometimes referred to in the Python community as thunder. Okay. All right. So when you do this now, outside of this class definition, when you import this class, you can really not access these variables directly. So that means you must have a method to do it. Okay. So that way you hide it. So let's talk about the bank account class a little bit before we go to the code. So in the bank account class, we basically have, of course, the bank has, a lot of attributes for its customers, but we're going to stick with only 3 of them for the interest of brevity. So we'll have a unique identifier, account number, and then each account's owner must have a name. Again, this will be just a single field. In reality, this could be multiple fields. And each account has a current balance. And this is what all we want to keep. Then if you look at the bank account class, of course, we can then define objects. Each object will be a customer. So if we are given these 3 variables, so integer, account number, a name, a string, and then finally it says balance variable, which is an integer. But I think I changed mine. I think I have float. That was kind of when I made the change, I went from integer to float. Okay. And then we have an application that will store this account list and move contents to the list for file persistence. So you have the class, which is this definition, and then you do have a utility function or utility method, set of utility methods that will allow you to create instances, create a menu and access accounts and all that, right? And then finally, for persistent data storage, we're going to just write these objects to a file and then read them, and then we can write them into a text file, we can write them into a binary file, and we will do both of them in the example coming up. Okay. So we have an initializer, or what we call a constructor, and then this will create instances. Then we'll have a bunch of methods to do operations on these bank accounts. So here's the definition. This is the class definition. This is the whole thing in the textbook version of it. Then I'm going to have my version. Let's start with this easy version and then explain things. Then what we will do is we'll go to the more complex version and then explain some additional goodies about this. All right, the first part, you notice at the top you have the class definition. So that means everything here is indented. Okay, so this portion has basically is data and methods. So they're all in this portion. So this is your class definition. Now I'm going to keep the class definition in a separate file, then I will create another file to use this class definition. But in reality, you could actually keep these in a single file and do it, but that's usually not recommended, and I will ask you to do it in a separate file in your assignment as well. Okay. So let's look at the portions of this class definition. The top portion is what we call initializer, or the constructor. You notice the constructor takes 4 parameters, and the first parameter is always self. So always here. right? So basically this is a reference to itself, the instance at this point. And then this is how it works in Python. It's a bit different. In Java, you don't have to put this there, okay, as a parameter. But here in Python, we have to put self there. And then there is number, name, and balance. So when a new instance is to be created, these three parameters will be passed. So these arguments will get parameters and create an instance. So when you create an instance, you notice it will check for the balance, and if it is negative, it will raise value error. So it will basically, this will automatically throw an error. Raise means just raise this value error. You notice in reality, balance is, in this case, is a float, or let's say an integer. It can possibly be negative. So it wouldn't raise a value error, but we want it to raise a value error. You can actually raise your own value error, and inside the error, you can decide to tell what's going on wrong here. So you can say negative initial balance, and this will actually will not allow you to create that specific instance. Now, what I'm going to do is, even though I'm using this constructor, I'll also use my data validation, methods, and I'll show you that. It's in the file actually. I've moved it into the top, and this will be kind of redundant to here, but I like to keep it so that you can see, another way of kind of dealing with this negativity issue. Okay? And then you have these definitions, or the assignment of three data members. So you notice on the left side you have the self, and then on the right side you have the balance. Now these parameters, actual parameters, can have any name. This can be N, M, and then BL if you want to. So this could have been this as well. But it doesn't have to be. They can be the same. If they are the same, then you have to actually use self to assign them. In Java, you could get away if they were N, NM, and BL. You could actually just say account number is equal to N, name is equal to NM, and then balance is equal to BL. But in Python, we have to use that self. Even though these were two different names, we will have to use that self. Otherwise, it will give you an error, and you can test it yourselves. Okay. So there's this little bit of a difference. The next thing is an accessor method. As we said, all of these data members, if you notice, they have all double underscores. That means they're all private. So because of this, iSight world actually cannot access any of these three parameters. So we can actually expose them using these accessor methods. In this case, we just have a read method, ID, which basically returns the account number. So whenever you call ID, so when you create, let's say, a new instance, right? So you say basically customer is equal to, you're going to call your bank account. This was the name of the class. Okay. And then you'll pass some values. So what is the first value? Account number. Let's say account number is 122. And then name, let's say Kutsal. All right. And finally, I'll put an account balance. Let's say it's $1 million. Right? And 50 cents. Now, if you call this now, what happens is you can then say customer dot ID, and this will work, but you cannot do customer dot underscore this is account number. Right? So in the outside code, this is not gonna work. Okay, so I'm gonna make that red. This will not work. Okay, so that's why you need to create this ID method so that you can access this value. Okay, and later on you'll see that we'll use it. Everything else, you notice, we cannot access. There's only one accessor. That means we can only access an ID of this specific instance. Now that doesn't mean that we cannot use their values. This is the beauty of object-oriented programming. So class definition, we will be able to print things. We will have methods to do other things as well, but we won't directly access these data members except this specific one because this one is exposed. There are mutator methods. Like for instance, we will be able to deposit and withdraw from the account. So for deposit, we need two parameters, self and amount to deposit. And same thing with withdraw. We have two amounts. And once we have those, what we can do is we can update the balance and see how much it's going to be. We can also go ahead and withdraw, and in this case, you notice what we do is we do check to see, make sure that the balance doesn't go negative when we withdraw, right? So what I'm going to do is I'm going to actually keep this here, but I'll also build my own checking within my code. Within my code, I'm going to check to see if the balance is available before I will allow the withdrawal. You'll see that difference as well. So, but internally, at least your class doesn't allow balance to be negative using this code at the bottom, right? So it basically checks to see if the balance is going to negative. If so, then basically returns the result. Okay. It doesn't raise any errors, but it basically doesn't update the account balance. So it kind of protects it itself. Now, the final method that you have in the class definition is what we call string method. So this is equivalent to your toString method in Java, if you recall. This basically allows you to create a representation of your account when account object is printed. So this basically is going to be displayed. So let me change the color again. So this is displayed when you call print. So when you say print customer, sorry about that, customer, this is what it will be printed. So you can actually, in Python, you can directly print your customer object, and what you want to be shown when the each individual instance of an object is printed is what this code will do. It's just a simple formatted text which will be returned and it will be printed, and later on we will use this. It's quite useful, and you do have similar thing in Java, but it really is not very similar. It's similar, but it's not exactly the same as this. Okay. So these are the basic methods for class definition, right? So this is toString method. We just talked about this. So once we have the instances, then we can start working on them. Now, let me now switch to the code, and then we'll look at how we use this class definition and then import it, and then so we can create instances of the class. As I said, what I'm going to focus on first is the textbook version of this without perhaps minor changes. And then I'm going to go to the more involved version of this. So first thing I want to do is I want to first look at the class definition. And so that's why I want to add, so I'll need bank accounts textbook open. And I also need use bank account textbook. So this is the program, client program, and this is the class definition. And then this will use this data. Let me open it up for you. So the data we have is this version. It's a text data. Is the first one is the account ID, other one is the name, and then the last one is the integer balance. Now, what we will do is in this example, what we will do is we'll create the objects, but save the data into a text file. And then when we read them, we read the text data, and then using the constructor, create the objects, so that we can then save them into a list. So this is what this program does, right? So it uses the objects, creates them, but it doesn't save them as binaries, as objects. It saves them as text, right? So there's a difference, a little bit of difference. We'll discuss that difference later, okay? So that's the data. So let's close this for now. So let's look at how this works. So first thing is, we basically have the class definition we just discussed, same as before. So there's really not much of a difference. It's the exact same one. So now let's look at how we use this code. Now, first thing we do is we import this class. At the very top, you see that I have to go to the file where this is and then import bank account. So the bank account is the class, and this is where it's located. As long as these two files, the client file and the class file, are in the same directory, you should just work. So I'm going to go ahead and run this and see what the result is. The result is at the top left. You notice it just basically prints all the customers, and you notice this is kind of a crude way of printing it. Later in the advanced version, I'm going to modify this and make it look a bit nicer. And then you notice it tries to deposit $100 and shows you what the account balance was before and after. And then there is an example of a withdrawal, and it basically shows what the account balance is before and after. And then finally it tries to withdraw a large amount which is not available. You notice it's about short $2,000, $1,500. So you notice this will not update. Even though you'll try to run this code, it will not update because it's prevented within the withdrawal method inside the class. So there are a couple of other utility functions here, so let me focus on those now, and I'll add more to this in the second version. So this version, you notice there's an open database file, there's a print database file method, and there's a get account method, and then there's the main. So within the main, what we're trying to do is we're trying to create an empty database. So this is basically a list, and what we will do is in this empty database we're going to use some of the functions that are given above. These are utility functions like open the database, print the database, get account from a database. So we'll use these functions to access the database, which is basically a text file. But I want you to notice what's happening here, especially in this open database file. So what we are doing here is we are importing the class bank account. You notice this capital name, right? So what we then do is when we get the data from the text file for each line, so what we do, we open the file name, okay? And then we go line by line. We say for line in lines. So that means lines is basically the file itself. So we go for each line and then we strip the line. So that means we clean out the white space. And then what we do is split the line and then unpack this to 3 variables: number, name, and balance, right? So once we unpack these names, what we then do is we use the bank account constructor, okay, and create a new instance of bank account. So what we're trying to do there is we are instantiating a new instance of bank account, and then we append this to our empty database. Remember, at the very beginning of main, database is empty. We now add things to our database. So what it does is basically it reads line by line, each line in the text file, and recall that the text file had these. So let's open up the text file to look at it. Okay, so the text file has these lines, so it reads these 3 numbers. You notice all these are text. So when you read from these text files, what you get is a string. So that means I have to take the first value, which is a number, and turn it into an integer. Take the second value and turn it into, just leave it as it is because it's a string and name is a string variable. And then finally take the last one, which is the balance, and take that and turn it into an integer. Again, this example, this is integer. Later on, I'm going to change this to float in my version. Okay? And then, so the key here is to recall that here, when I read objects from the text file, so the objects, they cannot be used directly. They cannot be put directly into a list. So what I need to do is just get the data, which is the minimum required data for this object, and use the constructor to create an instance of the object. So that's, this composition here does exactly that. So it creates an instance of a bank account object and puts it inside my list. Okay? And then print database basically goes through the DB and uses the print function. You notice here, when I say print function, this is the print function that is called inside the class. So inside my class, I have a function called underscore str. So this is the string function. This is the function that's being called when I say print an object. So basically, when I go through my DB, which contains bank account objects, what I'm doing is actually I'm printing each one. And since I already have an underscore string class or string method in my class definition, it knows how to print this specific object. Of course, I can always change how this is printed, and I'll show you later a version where I'm going to modify it a bit so that I can just show it in a different way. Okay. And finally, the get account basically goes through the DB, searches for a specific account number. If the account number is there, and then you return the account number. If it's not there, this returns none. Okay. So search through the account DB, search through the database, see if this account number is there. So go through all the accounts. Once you find account number which is given to you is equal to one account number in the database, then return the account number. You notice I returned the account, so I'm actually returning the object itself. You notice what I'm doing here? I'm actually saying here is the account number. Since I cannot directly access account number, I have to use the ID, which is my accessor method. This, if you run this, if you try to do this here, underscore account number, right? This is not going to work. The reason is because this is a private data and I'm outside of the class. I'm now inside this client file. Even though I'm importing, I don't have access to inner workings of private data. So that means I need to use the accessor method in this case. So use ID so that I can get the account ID for each one. So I'm going through the accounts which are each object and use this ID method to find the IDs and then see if the ID is the one that has been looked for. If so, I return the entire object itself. Okay. If not, I return none. Okay. All right, what else? Now, in this specific example, if you notice, the main itself is defined to be, there's a big try block. So a try block here, basically what it does is basically it tries to run these against the database. If there is any problem, file not found, the conversion problems, name problems, and then what happens is this try block will be run anything. If there's a problem, it will say error in account database, and at this point it's gonna basically stop the program. So it will print the error, okay, but it will also raise an exception. So this raise means that catch the exception and re-raise it. So what that means is you basically, the reason you catch it is you just print in this line and you raise it back. So if something happens, this is gonna break. Okay? So we'll come back to this later, but this is what this specific example does. What else are we doing here? We are opening the database right here. So here is the text file. Open database takes a file name and the database list, and then it prints to the database. That is the print function we have, and then gets the customer from 129. If the customer is in there, so this specific line here checks to see if anything returned. So if this is nothing returned here, this will be null and this will be false. So then you don't print anything. If something is returned, then you print all this. We know that 129 customer 129 is there. So you look at it, it's right there. Zoe is there. So because of that, all this code will work. If the customer wasn't there, none of this will work. So let's change this to, I don't know, some number like this. Run the same code. You'll see that the portion of the code, I mean, it's going to print the account database right here. But anything after this is not going to be printed because the customer is not in the database. Okay? So this is what this function does. Quite smart, nice way of looking for an object in a list. All right, so this is the rest of it. So the key issues here are working with instances of objects, right? So you got to be a little bit careful in terms of how you access them. If it's private, you need to have an accessor method. If it is not, then you can access directly. And in your assignment, in the Kafka example, I want all three attributes to be private. So that means you need to find a way to access them through get methods. Okay. All right, so we talked about accessor and mutator methods. Those are basically methods that access data or change data. Okay, data that's private. You can also pass objects as arguments, so methods and functions can get an object and work with this, right? So, and then they can also return objects as well. Right. Now, one of the things that you need to do is to decide what your class will do and what the client will do. I told specifically to you that calculations should be done in your class, and all the data should be kept in the class. And on the client side, you should have all the utility functions that you had before. You know, read a database from read a list of coffee objects from a file, write them to a file, and then what else? Print a given list, and then have a loop so that you can go through and ask various things, have a menu present to the user. And final thing I don't want to forget is you do have to have calculations that you do to get user input and then turn it into in this case now you're going to turn it into an object. In the previous case you were actually doing what you were doing was you were taking the values, calculate TEQ, TAC, and then put them into a list. Now I don't want you to do that. What I want you to do is take the values and create instance of coffee object and put it into the list. So the reason why you do this is as soon as you put the coffee object into the list, everything else should become accessible to you. Okay, and we'll talk about that with the extended example that I have, which is coming up shortly. All right, so in terms of slides, this is all I have. I'm just gonna go back now, look at an extended version of this, right? So let me close all of this and let me save them. So the next what I want to look at is two files I have. And you can take these files now and make them work. They'll just work right away. So for instance, what I'll do is I'll drag bank accounts, and I'll also grab use bank account and I'll put them right here. I really don't need both, but I want to show you what I did differently. And here are the account objects. This means if you have everything in the same folder, when you run your utility function, right? Again, without putting anything, since I gave you my objects, you can just run this, right? And I believe as long as you're using Windows, here I'm using Windows, you should be able to just say L and just leave it like that. Account objects is my default file name, and just load it. So now it's going to load, and let's see what it looks like. Now at the top of this file, it's going to print what it was printed earlier in the regular version of this file, that's the textbook version. What I did was I changed the print function a little bit. So now the print function has these double underlines and double underlines at the bottom, and then there is a balance that is I sum through. So here is a list of objects, and I also sort them. You notice they're now sorted by account number. I can also sort them in any other way, but at this point they're sorted by account number. And then I sort the objects and then go ahead and look at the balances, and then I also show what the total sum is at this point. The rest is pretty much the same, right? So I have before and after. Somewhere down here you see I say a message instead of just showing what the account was and after. I'm gonna actually tell the user that the funds were insufficient, so they couldn't actually do that withdrawal $80,000 because they had only $78,000 in the bank account, right? So that's that portion. In the second portion, what I'm doing is I'm now using objects, and I'm saving now the objects to the list, and I'm actually bringing them back. So the previous store function and load function, they're still there in the code as I'll show you shortly, but I also added two more codes, and I'm using the pickle class to write objects directly and read objects directly from the file. So since it may be, I think it's possibly it is operation OS specific, the way these objects are written, binaries are written, my version will not directly work in your case, but you can save it. You can actually run this and you should be able to save it yourselves. Okay. So let me try one more time. Maybe I can read this from the text file. Okay, so let's do that. I think I'm reading it from the text file, so let's do that. All right. So if you are using a Mac and if you're trying to do what I'm doing here, so what you can do is, instead of actually, you notice I'm actually taking the database which was read from the text file and putting it to my objects. So even if you do not have Windows, this should still work. Okay, just give it a try and let me know. In the worst case, you can just add your values. I think it should work. I think that's what I did. That's why I did this the other day. So this should work. So what is this code doing? So top part is pretty much the same. What I did was I added new functionality. I added some functionality in the class. I also added some functionality in the client. Now, I think I'm gonna go with the client version to show you how easy it is to actually go ahead and write these pickle class, writing and reading objects. So let me zoom in a little bit. Okay, I think this should be good enough. It should be visible. Okie dokie. Move this to the left a little bit, screen, so that we have extra room. All right, so let's start with this. The first, you notice that I'm importing pickle. I'm in the client code. I'm importing pickle so that I can write objects. Okay, and then the same line here. From bank accounts, I'm importing bank account. This time it's not bank account textbook, but it is bank accounts. Right, so it's the same thing. And I have a bunch of strings to display the menu, some of the error messages, welcome messages, and so on. So I decided to create strings for them. And then I have my global utility functions. So one of them is the validate function. Now this is the validate function I'm using. If you don't have one, if you like this, you can take it and just use it. You can use the same function. And there's an open database function which is the same as before. And there's print objects function. Now, if you notice this print objects function, now it prints the objects, and there's a title now. It prints a title, so it puts account number, name, and balance at the top, and then it prints in a certain format. So this line here prints double underline. How does it do that? Well, double underline is not a character you can find on your keyboard, but it's a Unicode character. So in Python, if you put this number, this whole thing, the highlighted portion is the Unicode character for double underline. So when you do this and multiply it 36 times, so what it's gonna do is basically on that line, it's gonna put 36 double underlines. Okay, so that is basically the underline which is right at the top right here. So this is this portion, all right? And then I go ahead and sort the list. So I'm actually using a sorted function which takes the list and sorts this. You notice my list here, input list, whatever list I give it to it, it will be sorted. So the input list is what this prints object method gets in. So, but notice this list has bank account objects. Now, bank account objects are not sortable. So you need to do a little bit of change on the class side to make them sortable. So I'll show what I did so that they become sortable, and we'll discuss that. But with default, they're not going to be sortable. It will raise an error, and it will basically give you an exception if you try to sort objects without building some additional functionality. And then what I do is I go ahead and print. This time again, I print double underline. And then what I do is I use the object and look at the bank account and print its total balance. What happens is total balance is a method that I now added to the bank account class. I'm using that to basically go ahead and get the total balance for this input list. So input list has objects. These are all bank account objects. I'm creating them using the constructor. And you also notice that the way I call this, I'm not calling it with an instance. I'm calling it with the class name. okay? Because this is a method, this is not an instance method, but this is a static method. Now, of course, static methods are defined with a static keyword in Java, but here we don't have that. So the way we do it is basically you define the function, and then the function can be called using the class name if it only takes, it doesn't need to access this specific instance. Here, actually, I'm not accessing any specific instance. What I'm doing is I'm just using the, this class method, which is a static method, which is available to all members of the class, and I'm passing it to a list of objects, which basically goes through and finds the total for me. You notice I cannot do this here. I cannot loop through the objects and list and do it because I cannot access the total balance. Balance is private, and there is no get method for balance. So it's hidden, but I can actually get the total. It's kind of hidden, I suppose, but you don't have direct access to change it. So you can only change it through withdrawal or a deposit. Okay. So this is called the static method of the class, and then you use the class name to access the static method. All right, so let's look at the load method. If you look at my load and store data methods, I have in these methods this load and store. These are using pickle. So right there, if you notice, it says pickle class has two things. It has pickle load and pickle dump. Load gets the objects from a file name, and the way you tell them that these are the objects I'm getting, you basically put RB. RB means read binary, so it gets basically the binaries from the file. So the account objects file that I posted within this folder has the objects, and now I can read them using this code. And it's a very simple code, as you can see. It's just one line. You take the objects, put it into a list. There is no append, there is no looping. It's much simpler. And then I basically find at the end I return it. Now there's also one more thing here. I passed the file name, but you notice I also put what is called the keyword argument to this file name. So basically what it says is this file name, if it's not given, it's going to be default to this file name. So I'm going to use this later in my main, where I will, in some instances, if the user doesn't give me a file name, I'm still going to go ahead and look for this file. If you look at my store data, I have an input list, which is my list that I'm passing to this, that I want to be written onto a file. Again, I have a default keyword argument. Basically, accounts object is my default name, which will go into the database. Again, the pickle dump is relatively simple. Pickle dump only takes the input list, the data, and then the file. So it's a bit more than clearly the load, but basically this now writes objects as binaries into the file. They're not text. You don't have to use the constructor back, so you can just write directly and read directly, and you don't have to recreate using constructor. That's the beauty of using this package. And then we have a new account. So this function here allows me to add accounts. If you look at the original bank account, you could only add them through a text file, and you just go type in a new line and then read them. But here I'm building, just like what you have in Coffee assignment, I'm actually building a way to ask user for a new customer, and an ID, name, and then balance. And I will come back to this function. This function has few things, but before I get to it, I need to explain a few other things, and we'll come back to this and why we're doing this ifs, else. And I think you'll benefit from this quite a bit, but I need to come back to this. So the get account function, as before, there's nothing here. It basically, all I added was basically went ahead and added a little bit of explanation. Why do we need to use this ID? Because account number is private. So that definitely explanation is there. All right, so main top part is pretty straightforward. At the very top, I'm putting 80 asterisks. So that's what's happening right there. So 80 asterisks, and then I have a line, this portion of the data, and then I put another 80 asterisks. All right, and then the separator is \n. So that means I'm putting them into separate lines. Right? So this is one print statement, but it has this separator, so they will go into 3 different lines. So I wanted to use a separator just to show you that how this works. Okay. All right, and then I have my database initialized, and then this portion is the same. I'm going to skip it. What I'm going to focus on more so, again, I print title here and telling you what this portion does. So let's talk about this other portion. So the menu part, okay? So first line here, 110, I'm basically now, I've built, remember in the code above, I'm just read the text file. So I read the text file and then put it into accounts database. Now this has database and it has objects. The way I did this was, remember I was using the constructor in that method, so that means I was reading the text, creating the instances of bank account and putting it into a list. Now I can assign this to my accounts objects. Now my accounts object starts with that default list of whatever it is in that text file. Okay? Once I have that, you see what is in the text file is this actually. So let me see this portion. Let me run this actually. Let's see what it is. So right here. So it has basically these customers with about $18.5 million of deposits. Okay. And then I have the menu. In the menu, you see I can load now my objects. So I'm going to say I can type the name, account objects. Right? It's a long name, and when I was preparing this, I was going back and forth. So that means I got tired of doing this. So that means you can type and load. When you load, you notice there will be some extra customers here, about 19.5 million. That means additional 1 million. And you notice I gave quite a bit of it to myself, $1 million. And there is $1,000 for Bobo. Bobo is a dog, and he has some cash, and he's also inside the account. So the default and this is different. This is added more. So now what I can do is, let's do the functionality a little bit. Let's play with this a little bit. So let's add now a new bank account. When I click on this, it says please enter the account number. Let's try to enter 120. You'll notice 120 is already in the database, and we know that account ID must be unique. Now the database will not check this. It will create 2 copies of the same thing, but I need to do it as a programmer on the client side. I have to check if this exists. So I'm going to click on this. You'll see it will tell me that please enter account number, and I say this account number is in use. Okay, so that means I cannot add it. So let's try one more time. Add, and let's put something that's not there. I know 4501 is not there, so let's put it in. Enter a name. Let's see who wants to be there. I'm gonna say Ajay. Okay. Oops, sorry, that's not. Ajay is there, and let's give him $500,000. Why not? Okay. So now, and then you notice he'll be there. He'll be sorted, and his number will be at the bottom. One more. Add one more, and then let's add 4502. Right. Now let me add some different numbers. So let me add this guy. Okay, we got a phone call. Okay. All right, I'm back. So let's add one more. Yeah, it cannot be Kutsal, so let's add someone else. I'm gonna add my wife. She needs more money than I do, so I'm gonna give her $2 million. Hey, why not? All right. So now what I want to do now is add one more. I'm gonna add some random number, 137. I'm hoping that's not a new customer. Okay, and give it $1. Okay. So you notice that customer with $1 is gonna be fed right there. I did not plan this very well. As you notice, the new customer did not fit quite well there. Okay. So this is what this program does. Now let's see how this is done. Let me also do a few other things here. So let's try to save all of this into a file. Okay. You notice it also gives me a default file name, and if I give it a file name, let's say do this, let me put a question mark here. you'll see now it will tell me that there are no accounts to display, load a file, or add new accounts. So what it will do is it will basically tell me that there is an invalid argument error. So right there. So it means either there are no accounts to display or load, so that it cannot save, or file name is not there, but I'm actually doing is I'm giving it a file name which is not acceptable so that it doesn't save it. Okay. So we will check that as well. So hit enter. Let's see the menu. So at this point I'm going to quit because I don't want to save that new customer up there. So I'm going to quit. So let's go back to the code now and let's see how certain things are done. The first thing is sort. So how do we sort? The customer objects or bank account objects, by default, they are not sortable because there is no way to compare them. So what you need to do is go to your class definition, add specific two methods. These are methods that will allow, together they will allow you to sort your accounts. Okay. So everything else is pretty much the same. There's nothing here. I'm not really changing anything over here. So what I did was I added this total balance as a member method, and then I added this kind of modified the string itself. So now I show the account balance with these 10 digits, right? Left justified, 10 digits left justified, and then I have a $sign, then I have 15 digits right justified, right? So the balance is now a float, and at the same time you notice that I'm actually kind of organizing this a little bit. This is really pretty much it in terms of bank account. What I have in the class is two more things. I was talking about earlier the way I compare and sort my bank account objects. So to do that, I need two functions. One is to check to see how I can check the equality of two bank accounts, and the other one is to see how I can check to see if two bank accounts are one is greater than $. So here I'm actually using a function. This is an LT function. So this is a less than function, and this is equality function. So this is your equals in Java, and this is less than in Java. So what I'm doing is actually I'm writing these two functions. So what I'm saying is for this function, equality means if the two bank accounts do have the same account number, that's what equality means. So I can actually change this any way you like. If I want, I can add more conditions. Well, not only they should have, the same account number, but perhaps they also need to have same name. Name is equal to, you notice I'm using, it has to be other. So other is the one that is being passed to here. So I'm going to check to see and account number. Okay. So this is another option. Right? Ooh, what a terrible spelling there. Okay. So we could do this as well. So that means if they are both the same, then they will be deemed equal. Again, so this is your decision as a class developer. You decide how the equality should be. Coffee objects, if the brand is the same, perhaps you can assume they are the same. And then for less than, you have to find one attribute they'll compare. For coffee, perhaps you may choose the demand, so that if the demand is higher, or you may choose the brand, so that they're alphabetically ordered. So it's up to you. In this case, I chose actually the account number. You see, less than means if an account number is less, if it is true, if this current account that I'm giving self is less than this other, then I'm going to return true. So this means if I have two objects, object one, which is the object I'm comparing, and then another object, so what it will do is it will compare them, and then if one account number is before the other, it will be sorted. It will be in true, okay? Otherwise, it will be false. That's what these two functions do. Relatively simple, but it's kind of hard to grasp how you compare two objects. This is how you do them. So you build these two functions. One last function here is total balance. So what I'm doing is actually I'm calculating the total balance inside. Why do I do this? Because total balance in this setting does not have any get method, so I cannot access it directly. I can only print it using the string. So what that means is I need a way to sum them up, and this is that function. So it takes input list, which is a list of objects, and then it goes through the list and basically sums. Since I'm inside the class, remember this is the class definition, I can now access for any given object in the list, I can access this balance and then sum them up, right? So, and then what I need to do is I can then return the sum. So what this function, when it is called as a member function, and it will return this sum. This is a static function because it doesn't depend on a specific instance. It actually can be run directly with the bank account as the class name. All right, so finally, let's talk about a little more things inside my client function in the client file. In the client file, I do a few things. I have a bunch of try and except statements so that I'm checking every time to see things are working properly. So I don't want to raise an error, raise an exception. So this is all these tries are doing that. So let's explain some of that. So the first one is I'm going to show the menu. In the menu, that doesn't look nice. All right, here we go. In the menu, so if it's not done, I'm going to continue. So I first set my database to whatever is read up here. It takes the account number, asks the account number from the user. So far, so good. And then assigns this account number to a customer object. So it basically grabs a customer object with this account number from the list and puts it into customer. Now, if this is a totally brand new account number, this is going to be null. So it will return nothing because there is no account object associated with that account number. If, however, this number that you're given is that already belongs to a customer, that customer object will be returned. So the customer now will have an object in it. It will be either null or will have an object. So that means if the customer object is not there, if it's not really an existing customer, I go ahead and ask for the name. If it is, then I don't. What do? I basically say print this account number is in use. Okay, and then I return the input list without changing it. Right, so that's what I'm doing. So here I basically then I get the name, I get the balance, right? So I basically ask, and each time I ask, you see I'm using my validate function to make sure that I'm getting proper numbers, right? I also use the validate function here. So the same validate function I'm using to make sure that I'm getting numbers. Account should be a number, balance should be a number as well. And then once I finish this, basically I create the object, bank account, with the account number, name, and balance. I use the constructor or initializer, create the object and add it to the list, and then print the list. Okay? And at the very end, I basically go ahead and return the list. Right? So I always return the list. Sometimes I change it, sometimes I don't change it. Okay. All right. So what else I'm doing in the main? Let's go back. Let's see. So that's this portion. So the key is I'm trying to look for a customer. If it is there, I grab the object and assign it to customer. If that customer has an object in it, then I don't ask anything else. I don't ask the user. If no, then I go ahead and ask the name and a balance. All right. So in the second portion of here, when the user says save, I basically ask for the file name, right? And then I ask it separately. And then if file name, what that means is, if the file name is given, right? That means if the user types something, I'm going to call whatever is typed, I'm going to take it and call this function with that name. So I'm going to send my account objects list and with this file name. If the file name is not given, in that case it will be a null string, and the null string, you know that it will be false. So it will be this line. So this time I'm going to call the same function. You notice now I don't give it a file name. Now how does this work? Because the file name is a keyword argument, it has a default. That means if I don't give it, I can actually give this function. I can call the same exact function with two different parameters. And that's what I'm doing actually. Check the file name. If it's not given, just use the default. If it is given, then use that file name. And if there's an exception, if this exception occurs in here, right? So if suppose you cannot write it for some reason, let's say you have no access to any drives, things like that may occur, you can actually cast the exception. So here I cache the exception, I give it a name. So this portion, I'm actually giving my exception a name, and I'm printing it. I'm trying to see what the exception is, and I print some other messages, and then I say input, hit enter. This basically allows me to hold the screen at that point until user hits, and again, I'm not doing anything with that input, but actually it holds the screen, and then it gives user a chance to just hit enter and move on. Alright, so that's what this portion does. For print, all I do is just use my print objects function. I put objects and print this. If there is an error, somehow I cannot find this objects. It should not happen in this code, but I'm just giving you as an example. In this case, you can actually print a message. This could be an unbound local error. So if account is not given to here, but in this case I do. I create the account in this function scope, so it is always there. But nonetheless, this is how you check to see if this account name is already defined within this scope. Okay. Again, I'm not doing anything here, so I basically first cache the account unbalanced error, and then I cache all the errors, and then just pass, do nothing, and just let it be. Okay. And then if it's L load, then I do the same thing. I try to get the file name. If it's not there, I basically load the default file right here, default. Right. This basically the loads the default. If you look at the load has only one parameter, and which is a keyword parameter, and basically it has only file name as a parameter. To load, you really don't need to pass your objects file. What you do is you load, and then whatever is returned, there will be a load. In the load function, there will be a list created, and you'll assign that to account objects. This is very critical. So if you look at my load, let's go back and find this load. So load data, I can actually find it from here. Load data. If you look at the load data, so notice this returns account objects, same name, but actually it creates it right here. It creates it and returns it. I don't need to pass it here. It's not filling in the object list I'm giving, because even if I want to give a list to this, that list should have been empty. And there's no need to give an empty list here because it's going to create it anyways. Okay. So that is that part. And what else I'm doing? Then the load, if you say load, if the user says load, again I check the file name and use two versions. If the file somehow is not found, this can occur. Even though I have a default file name may not be there, it may not be saved, and I basically cache that error and then print a message that says file doesn't exist. At the very end, if everything goes well, if there is no exceptions, well, no matter what, I actually go ahead and print objects. Print the list as at that point. Okay. All right. Yes, that's what I'm doing. So, all right. And then finally, when the user says write, I basically write objects. I'm using a W, withdrawal. I basically go ahead, get the account number, again check to see if the customer is there. If the customer is there, I ask for the withdrawal amount, and then I try to do the withdrawal. At this point, if the withdrawal is not enough, I basically added a line inside the withdrawal code. It tells us that this amount is not available, and that I did in the class. So if you go to bank account class, you go to withdrawal, right there, I actually print this right here. I made a change. I said funds are not sufficient. If this doesn't work, this is what is going to be printed. And if you look at my main, so this is what the message will show up here. So if the W doesn't work, right here it will show up, right? If the customer, if it exists, you do it. And if else, you say, okay, the account number is not valid, because if you cannot find the customer, that means this customer doesn't exist in the database. And deposit is the very similar way. So here I'm depositing. There is no need to check anything because you can always deposit as long as it's a positive amount, and I validate that right here. And then finally, I basically print. If the customer is not there, I say this is an invalid account. And there is all there is to it. So I think this kind of helps you put things in perspective in terms of classes. And the main idea is to encapsulate things in the class and hide as much as possible, but nonetheless allow client code to be able to work with your objects. think I'm gonna stop here. I don't want this video to get too long.